Hey guys, first of all, a late Happy New Year to all of you. I'm today excited to announce that I'm starting a new series on this channel where we'll be diving into problem solving together. So, from time to time, we'll tackle different coding challenges and I'll try to break down these problems into steps as much as I can. And in today's video, we are actually starting with a classic, which is the two sum problem. So I will be showing you how to solve this in C#. So let's get started. So here we are given a list of numbers and a constant value. What we have to do here is go through the list and see which one of these which two numbers will be returning as this constant or this target value. We'll start basically with the first number, which is 10, and then what we will do is add it up to 15. See if that returns us the target value. No. Then to 3, if not, then we move to the next one, which is 7. Now there might be cases where we have to basically increase in iteration. So in this example, for instance, 3 if added to 2 won't give us 6, if added to 4 won't give us 6 neither. So then we have to move to the second value, which is 2. So when 2 is added to 4, which returns us the target. To be able to achieve this, we have to use well, basically there could be different ways of solving this. It's not limited really, and here I'm going to be showing you two ways of solving this. You have one which is more optimized and the other one which is not really. So we'll start with the less optimized one. The less optimized one actually gives us a quadratic time complexity with constant space complexity. So let's see how we would solve this. So here what I'm actually doing is that I'm looping through this list, and then I'm checking if it adds up to that, if the two sum adds up to the target value. If it does, then I should be returning what I have and not continue on with the loop. So this is what I'm doing. Now if I run this project here, I should get 10 and 7. Why is it like that? Oh my bad. So yeah, that's not a good way to write this. Yeah, so we should get 10 and 7. Basically this is giving us a quadratic time complexity like I said, so let's take a look at how it's doing that. Normally a for loop gives us a time complexity of so a linear time complexity. So right now we are using the loop 2 times because we have to go through like 2 numbers. So it's like this. So it's this first one here, and then the second one would be this. So this is quadratic. Now let's take a look at how we would write the code for a more optimal version. So in order to do that, I'm going to be using a hash set. And why a hash set? Because the hash set, it does not store duplication of any elements, and also it doesn't buffer about the orders. So upon its search in the hash set, or even for its addition or removal of its elements from the collection, the time complexity would generally stay constant. And this is why we are using a hash set. So let's see how we would write this code, right? So if I run this program now, I should get 7 and 10. So let us understand why this program was written as such, right? So what we are trying to do here is, I'm going to check if, let's say we have these values. So we have a target 17, I'm sorry, and I'm going to be extracting this target with these, subtracting this target with these values. Now if I subtract it, and I basically what I do is I check in my hash set if I already contain this value, and if not, then I should basically store it in that hash set. And then if found, then this is going to be what we are returning. So it's another way of finding the two-sum, of solving the two-sum problem. So here I have 17, and I will subtract it with 10. I should get 7. Now 7 does not yet exist. Sorry, is it 7? Yeah, 7 does not exist yet in my hash set, so I'm going to be storing this item 10, right? Now I'll check if 17 if 2 exists. If not, I will store 15. I will subtract it with 10, and then I should get 7. So 7 does exist, so I'm going to be returning this value, because now I have found the value which basically gives us what it needs to solve to get the targeted value, right? So this is one way of doing this. Now why is it more optimal? Because it gives us a linear time complexity. Now how does it do that is, the for each is going to be giving us a linear time complexity. Now the hash set is going to be giving us a constant it's going to be giving us a constant time complexity. So then the overall of this algorithm will be linear. So this. And its space complexity will also be linear, because now what I'm doing is that I'm storing each of these values in my hash set. So this is why it's giving us a space, a time complexity of linear. Yeah. And yeah, that was it for this problem solving of a two-sum. And I hope that helps you understand a bit how to do this if you were struggling with it, if you're a beginner or you're just a professional trying to just get back to solving problems also. So yeah, thank you guys.